Yes,
Hello,
ma'am.
Yes,
student.
yes, ma'am.
Okay, so good morning, one and all. So we'll start the session. So in the last lecture, we started the point video display devices. This was the third point from the syllabus from the first chapter. First point was introduction to computer graphics, where we discussed about the definition of the computer graphics. In the second point, we discussed about applications of computer graphics. So total 8 applications we discussed in computer graphics. And after that, we started the third point from the syllabus from the first chapter, that is video display devices. And under video display devices, we have discussed about cathode ray tube. So we have discussed cathode ray tube with the help of its structure. So how it works exactly. So with the help of this diagram, so still some of the students they are coming. It's my request to all the students, within first maximum 10 minutes you should admit. So that will be better, because in between again we are facing the range problem. Okay, we discussed this diagram. So how cathode ray tube works. So once again I will repeat, cathode ray tube works. So from the back side of the monitor, one cable is connected from the CPU to the monitor, and through that cable the electrons are emitted. The electrons are in the form of voltage, 0 voltage and 5 voltage. So 0 voltage indicates 0 and 5 voltage indicates 1. So these are the two bits. So as computer knows only binary, so it works with the binary data. So binary data is nothing but 0 and 1. So these bits are emitted with the help of electron emitter, and these electron emitter is just trying to reflect the electron beam on the screen. So this electron beam is going through focusing system, accelerating system and deflection system. So focusing system, it just focuses on the screen, whatever screen is there, so it is not going outside the screen. Accelerating system is responsible to control the voltage of that electron beam, so whether it is coming fast, slow or medium speed, etc. And deflection system, so they are just trying to deflect the electron beam on the screen, and with the help of which the spot is get generated. So that spot is also called as a pixel or point. So it is having its own x coordinate, y coordinate and its color, and it is get generated on the phosphor coated screen. So screen, so whatever picture tube we are calling, so it is coated with phosphor. Speciality of phosphor, it just highlights the spot whichever is get generated by the electron beam. And further, this particular tube is vacuum tube. So like this it works. So this is the working of cathode ray tube, which we discussed in the last lecture. After that, we discussed some points regarding this CRT. So this CRT is called as a refresh CRT, because within 1 second almost 65 times it will be get refreshed, and that's why it's called as a refresh CRT. So within the for 1 second almost 65 times it will be the electron beam is going to hit to the screen, and that's why that particular spot is get highlighted. So that's why it is called as a refresh CRT. Further, beam of electrons hit phosphor coated screen, light emitted by phosphor. So phosphor emits the light. This is the specialty of phosphor. Direct electron beam to the same screen repeatedly, keeping phosphor activated. To keep the phosphor activated, the beam is repeatedly going to strike on the screen. The frequency at which a picture is redrawn on the screen is referred to as the refresh rate. So refresh rate, that is per second 65 times the electron beam hits the screen. So this is nothing but the refresh rate. The maximum number of points that can be displayed on a CRT is referred to as the resolution. So we discussed the resolution. What is resolution? Maximum number of points displayed on the screen. This and after that we started the display principle. So in the last lecture we discussed about the display principles. Let me admit one more student. Okay, so in the last lecture we started the display principles. So what is principle? So this is the methods used by the cathode ray tube to display the picture. to display the picture. So there are two methods, raster scan display principle and random scan display principle. So either you can call it as a principle or method. So these are the methods, these are the techniques used by the CRT to create the picture. So first of all, we discussed raster scan display principle. So once again, I will repeat the raster scan display. So CRT display principle, raster scan display, it is based on TV technologies. So whatever technology is used in television, so it is nothing but the raster scan display principle. So in the last lecture also I told that. So if signal is slow or low or weak, so in that case we are able to see small pixels, rectangular patterns on the TV screen in the form of red and black, in the form of red and black. So that is nothing but the pixel. So it is based on the TV technology and how it works. So in raster scan display, electron beam sweeps across screen one row at a time from top to bottom. So it sweeps at a time, one row at a time. So it sweeps from left to right, from top to bottom. So if you are looking to these four diagrams, in the first diagram it is shown that electron beam has traveled from left to right on the first scan line. So these horizontal lines are called as a scan line. Each row is referred to as a scan line. Now if you are looking to the second diagram, so in the second diagram it has covered almost six lines. So it is just looking. So here the picture is nothing but the triangle, and that triangle is drawn. So in the first line only one point of the triangle is coming, so that pixel is get highlighted. So remaining pixels are not get highlighted, but still it visits all the pixels on that scan line. Again in the third diagram it has completed almost 75 part of the picture. So like that, if you are looking to the first scan line, one point is coming. On the second scan line, 2 points are there. On the third scan line, 2 points are there of the triangle, like that onwards. Like that onwards. In the fourth diagram, it has completed the whole triangle. So actually, what is the basic disadvantage of this raster scan display? So electron beam visits each and every pixel on the screen. So it will not think whether the pixel is the part of picture or not. So if on the first scan line, if suppose there are 10 pixels, and out of 10 pixels, how many pixels it have to draw? It have to draw only one pixel, but still it visits almost remaining 9 pixels unnecessarily. So this is the major disadvantage. That is, so it is visiting each and every pixel on the screen. It totally depends upon the resolution. If the screen resolution is 10 by 10, that is 100 pixels, so it visits 100 pixels, and maybe from that 100, maybe only 10 to 15 are the part of image. So only these pixels it have to highlight, but to highlight these 15 pixels, so it have to visit each and every pixel, almost 100 pixels. So visiting time will be get wasted unnecessarily, though the pixel is not a part of picture. So this is the major disadvantage of raster scan display. So what the clear idea about these four diagrams? Hello, students.
Yes, ma'am.
So can I proceed further?
Yes.
Okay. So we'll proceed to the next point. So here we have taken the example of CRT. So in raster scan display. So in raster scan display, CRT takes the help of one buffer, and that buffer is called as a frame buffer. So it is also called as a refresh buffer. So each device is having its own memory. Each device is having its own memory. So like CRT is also having its own memory in case of raster scan display. So when CRT
Yes,
is
ma'am.
using raster scan display principle, it takes the help of memory, and the name of that memory is nothing but the frame buffer. What is memory? It is nothing but the storage. So it is the storage. So what kind of what it stores? It stores the picture information. Picture information is stored in the refresh or frame buffer. So this picture information is stored inside this frame buffer. Picture information is stored inside this frame buffer or refresh buffer. Further, how the information is stored, either it is stored in binary way or it is stored in decimal way. So in this example, if you are looking, so over here in the last lecture I told about this example. So at left hand side, the face diagram is shown. Picture is nothing but the face, and part of this picture, it is shown on the screen. So this is nothing but the screen size. So whatever rectangle is shown, part of the face, I'm talking about part of the face. So this is the part which we are able to visualize on the computer screen. So with respect to this part, so this is nothing but the frame buffer. So at right hand side, the frame buffer is shown, and inside the frame buffer, if you are looking, so what kind of data is there? So decimal data is there. So the data is again 3, that is 2, 7 and 1. So 3 decimals are there, 1, 7 and 2. So 2 is nothing but the color of the outside pixels. So these are nothing but the outside pixels. So are you able to see it, students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes,
So
ma'am.
I'm moving the mouse. So these are the pixels whose color is nothing but 2. So these are the pixels whose color is nothing but 7, and these are the inside pixels whose color is nothing but 1. So you are able to understand the difference between this 1 and 2, and this is the 7. This is totally dark. Okay, so these are nothing but the 3 color shades, and again over here 2 pixels are there, their color is again dark, and that's why over here 7, 7 is there. So this is nothing but 6 by 8 raster. So it is also called as a raster. So whatever rectangle, whatever matrix we are showing, so its order is nothing but 6 by 8. So 6 by 8 frame buffer is shown over here. And further, I told you that, so it is the binary equivalent. So how many bits we used over here to represent the color? In the last lecture, I told. How many bits we used to represent one color? Come on.
2 bits.
Huh? Hello? So how many bits we used over here? 3 bits. So we have used 3 bits. So as we use 3 bits, so how many color combinations will be there?
8 combinations.
8 color combinations will be there. Good. So these 8 color combinations are nothing but, so in terms of binary equivalent, so first color will be, in binary equivalent, the first color will be
0, 0, 0.
good. So 3 zeros, 0, 0, 0. So that is nothing but the decimal equivalent 0. Next color will be 0, 0, 1. The decimal equivalent will be 1. So here we have used the color 1. And again, so 3 colors we have used. So can you tell me the binary equivalent of these colors? Binary equivalent of these colors. 3 colors we have used, 1, 2 and 7. So what is the binary equivalent of 1?
0, 0, 1.
0, 0, 1, 1. 0.
Good. 0, 0, 1. What is the binary equivalent of 2?
0, 0.
0. 0, 1, 0.
0, 1, 0. And what is the binary equivalent of 7?
1, 1, 1.
1,
1, 1.
Very nice. 1, 1, 1. So these are nothing but the 3 color shades which we have shown over here. So only 2 colors we have taken in this example, black and white. So this is nothing but the example of frame buffer. So in the assignment, I have asked the question, explain frame buffer with the help of example. So you need to explain the frame buffer. So frame buffer comes, this is the storage used by the raster scan display principle in CRT. So that's why you need to describe a whole part of the raster scan display. And this is nothing but the example. So over here, the example of face is taken. Not necessary, you can take your own examples also. So in the last lecture, I told that you can take the raster of 5 by 5. And in that 5 by 5, you can draw your own initial. So I given my own example, that is, my name is Vanita. So my first initial is nothing but V. So if I want to draw V, so I will draw the V like this. Okay. So if this is the raster, so I will draw V like this, and whatever pixels are get highlighted, so related to these pixels. So mostly I will use only 2 colors. One is the white and another is the black. So I will show V later. So whichever pixels are coming under V later, I will show with the help of black color, and other pixels I will show as a part of white color. And I will say black is nothing but the 0 and white is nothing but 1. So like that, I need to fill the data inside the frame buffer. So if I take 5 by 5 raster, so over here the again the frame buffer will be of 5 by 5. So matrix should be again 5 by 5, and over there 0 1 should be there. Or you can use any other colors also, like this example. So here we have used three colors, 1 7 2. But actually in paper, if you want to draw it, so it is quite difficult to show the color shades. So that's why I said that use only two colors, black and white. So you are able to use your ink pen. So ink pen, that is nothing but maybe green color, blue color, and other color will be the white color. So two colors you can show on the paper. So what the clear idea about this raster scan display? Any doubt?
Yes, ma'am.
So
No.
here again one more example is shown over here. So this is the example of X. So the picture is nothing but the X. So you are able to see over here. So finally in the last diagram X is drawn. So again over here two colors are used. So I think you are unable to see the frame buffer. So I will just run the PPT. So here this is nothing but the frame buffer. So this is the frame buffer related to this diagram. So you are able to understand. So first two pixels are 0 0. That is 0 is treated as a white over here and 1 is treated as a black over here. So third pixel is having 1. So this 1 is reflected over here. Again next three pixels are white, and again next pixel is dark black, and again last pixel is white. Is it right? So in the same fashion over here, first three pixels are white. Next pixel is having 1. So that is nothing but black. Again 0. So this is white. And again 1. This is black. And again last two pixels are white. So everybody getting it? Hello?
Yes, ma'am. Yes, ma'am.
Yes.
So I'm moving the cursor
Yes,
from
ma'am.
frame buffer to this picture. I'm moving the cursor from frame buffer to the picture. So in the example, if they ask example, you need to give your own example. You can take the same example or you can take your own example. As I suggested, you can draw your own initial. So accordingly, you need to fill up the frame buffer. तुमचं पिक्चर जर वेगळा असेल तर तुमच्या फ्रेम बफरचे कंटेंट्स पण वेगळे येणार आहेत. So accordingly, you need to draw the example. So this is nothing but the best example of frame buffer. So hope with this example you got the clear idea about the frame buffer. Okay, so frame buffer. What is frame buffer? It is the storage used by the CRT in raster scan display principle. Okay. So again over here the information about frame buffer is given. So how the frame buffer is characterized? Frame buffer is characterized by size, x, y, x coordinate, y coordinate, and pixel depth. Pixel depth is nothing but the color of that pixel. Again the definition of resolution is given over here. So over here the screen size is assumed to be 1024 multiplied by 1024 pixels. That is total 1024 multiplied by 1024 pixels we are able to display with the help of screen. So this is nothing but the screen resolution. So this is the standard resolution, whichever computers we are using nowadays. So they are having this kind of resolution. And further again they have given the definition of bit planes, or bit depth is the number of bits corresponding to each pixel. This determines the color resolution of the buffer. And at right hand side over here, so the frame buffers are shown. So number of planes are shown over here. So over here 1 2 3 4 5 6 7 8 9. So almost 9 to 10 frame buffers are shown. So this depends upon the number of bits used to represent the color. And again below it is shown, if we are using 8 bits per pixel, so we are able to get 256 different colors. And if we are using 24 bits per pixel, we are able to get 16 million different colors. So this is nothing but about frame buffer. So again over here, this is again for your information, I have shown this diagram specifying color. So mostly in case of color CRT, so these are the basic colors used: red, green, and blue. So again 3 different guns are there. So 3 different guns are coming towards the screen. So different types of guns we are able to use. So here a red gun is shown. So red gun is having total 8 bits. So 8 planes are there. So each plane is storing 1 bit. So like that 8 planes, they are storing 8 bits. So this is nothing but, if I whatever cursor I am showing on this pixel, so this is nothing but the corner pixel. So this corner pixel shows the color. So color bits are stored over here. So over here, three planes are there. Practically in the diagram, we are able to see three planes. So three bits will be there, 0, 0, 0, like that. So if we are using eight bits, so eight planes should be there. So like that, red color is represented with the help of 8 bits, green color is represented with the help of 8 bits, and blue color is represented with the help of 8 bits. So total, to highlight one pixel on the screen, we have used total 24 bits. So these 24 bit plane, so 8 bits per color gun. So how many colors we are able to get? So we are able to get 2 raised to 24. That is nothing but these many colors we are able to get. So nowadays, whatever color CRTs, whatever color TVs we are using, so these color TVs, they are able to reflect these many colors, 16 billion, almost about 16 billion colors we are able to see on the screen. So this is about the guns. So this is the example. Actually, it is not required to study. Just this is for your information. Okay. So got the clear idea? After that, we discussed about aspect ratio. Aspect ratio is nothing but the width to height ratio. And I said that this aspect ratio is related to pixel also, and it is related to screen also. So if we talk in terms of pixel, so pixel width divided by pixel height, it is called as a aspect ratio of pixel. And if we talk with respect to screen, so pixel screen width divided by screen height, it is nothing but the aspect ratio of screen. So again, it depends upon the display device size. So mostly if we take mobile and computer, so computer screen size is different and mobile screen size is somewhat different. So depending upon that, aspect ratio is calculated. So these are the two examples here shown. So over here the pixel is looking like a square, and over here pixel is looking like a rectangle. So it depends upon the display device. So as I given the two examples, so you are able to differentiate. So if you are looking to the computer screen size, it is different, and mobile display, it is different. So on mobile display, width is very small and height is big. So like that, aspect ratio differs based upon the device, whichever display device we are using for display purpose. So this is about aspect ratio. So whatever up till now we discussed, this is totally related to the raster scan display. Hope with this you got the clear idea about raster scan display. Any doubt? Hello, students, are you listening to me?
Yes.
Yes,
Yes,
ma'am.
ma'am.
So actually,
Yes.
actually
Yes.
this raster scan display is used basically in case of pictures which are too much dark. So I given the example in the last lecture. If you take two shirts, one is the plain shirt and another is the lining shirt. So if I want to prepare the design of these shirts, so for plain shirt, we are taking the help of raster scan display, and for lining shirt, we are taking the help of random scan display. So again, applications are there. So each display principle is having its own application. So finally, after discussion of random scan display principle, we'll discuss the difference between raster and random also. So with this, can I proceed further to the random scan display principle? Almost this is the
Yes, ma'am.
kind of revision. So in random scan display principle, so again, it is also called as a calligraphic display, also called as a vector display, also called as a stroke, also called as a line drawing graphics. So better you can just keep in mind, it is also called as a line drawing graphics because so it draws the picture in the form of line. So in previous principle, we drawn the pixel with the help of pixel. So we have drawn the picture with the help of pixel. मागच्या raster scan display मध्ये पिक्चर कसं ड्रॉ केलं जात आहे in the form of pixel by pixel. But in case of random scan display principle, picture is drawn with the help of lines. So that's why line is called as a basic unit of picture in random scan display. Line is called as a basic unit of picture in random scan display, and pixel is called as a basic unit of picture in raster scan display. Once again, I will repeat. So pixel is called as a basic unit of picture in raster scan display, and line is called as a basic unit of picture in random scan display. So in random scan display, the picture is drawn in the form of line. So it is the collection or combination of lines. So how electron beam is directed? So electron beam directed only to the points of the picture to be displayed. So whichever points are required to be drawn, so only to these points, only to these pixels electron beam visits. So it will not visits other pixels which are not part of picture. So this is the advantage, or you can say that it saves the time. So unnecessarily visiting the pixels which are not a part of picture, so that is avoided in case of random scan display principle. But it draws the picture in the form of lines, it will not draws the picture in the form of pixels. So it is also called as a vector display. Electron beams trace out lines to generate pictures. Picture stores as a set of line drawing commands. So how the picture is stored? So picture is stored in the form of commands. So these commands are called as a line drawing commands. So in previous we discussed about the storage. The name of the storage is nothing but frame buffer. So how the picture was stored inside the frame buffer? In the form of pixel intensity. That is nothing but the color of that pixel, either 0, 1 or 1, 2, 7, like that. But here how the picture information is stored? So picture information is stored in the form of commands. And this storage is referred as a display list, or it is also called as a display file. It is also called as a vector file. Okay, so in short you can call it as a display file. So we'll see the example of display file. So this is the working of CRT in case of random scan display principle. So again, same example of triangle is taken over here also in the first figure. So the beam, electron beam is pointing to the line end point. So it want to draw this line. So it is positioned over here, that is to the first end point. So in the second diagram, it has drawn the first line of the picture. In the third diagram, it has drawn the second line of that picture, and in the third diagram, it has drawn the last line of the picture. That is nothing but the triangle. So as it draws the picture in the form of lines. So only these many pixels are get visited by the electron beam. So other pixels are not get visited by the electron beam. So like this, it saves the time to draw the picture. So this is nothing but the random scan display principle. So what this diagram? Yes, students.
Yes, ma'am.
So you can take your own example also. For example, so say Aishwarya. So if I want to draw A, so on this screen, so I have to, how many lines we have to draw? A. I want to draw A. Come on.
3 lines.
So three lines we have to draw. Three lines we have to draw. This will be the first line. This will be the second line. 1, 2, and third line. So for that purpose, first of all, you have to move the cursor over here. Electron beam should be moved over here. So first line should be drawn, then second line should be drawn, and then third line should be drawn. So for the third line, again, first of all, we have to position the electron beam, and then the line should be drawn. So accordingly, the contents of your display file should be there. So this is the example over here. So if you are looking towards this example in the diagram, so picture is nothing but this line and again this line. So over here 2 lines are there. ही पहिली लाईन आहे आणि इथून दुसरी लाईन इथं थोडीशी टर्न झालेली आहे, ही दुसरी लाईन आहे आणि इथं तिसरी लाईन आहे आणि ही चौथी लाईन आहे. So this is nothing but the picture which is drawn with the help of random scan display. So over here, if you are looking to these lines, so what are the commands? So these are nothing but the commands which are used to draw these 4 lines. So everybody is able to understand 4 lines are there. या पिक्चर मध्ये या स्क्रीनवर टोटल 4 लाईन दाखवलेले आहेत. ही पहिली लाईन आहे, मी कर्सर मूव्ह करते, ही पहिली लाईन आहे, त्याच्यानंतर ही दुसरी लाईन आहे आणि ही तिसरी लाईन आहे आणि ही चौथी लाईन आहे. अशा टोटल 4 लाईन ड्रॉ केलेल्या आहेत. मग त्या 4 लाईन कशा ड्रॉ केलेल्या आहेत? तर डिस्प्ले फाईल मध्ये त्या कमांड्स दिलेल्या आहेत. So these are nothing but the commands. This is nothing but the storage of CRT in random scan display. Okay, so this is called as a display file. त्या स्टोरेजला काय म्हणलंय आपण? डिस्प्ले फाईल. आणि त्या डिस्प्ले फाईल मध्ये काय असतात? कमांड्स असतात. So these are nothing but the commands. So these are some of the sample commands as it is drawing the lines. So first command is nothing but move to 10 30. जर तुम्ही ही कमांड कन्सिडर केलात तर तो काय सांगतोय 10 30. एक्स कोऑर्डिनेट 10 आहे आणि वाय कोऑर्डिनेट 30 आहे. 10 30 म्हणजे कुठला पॉइंट? सो दिस इज एक्स ऍक्सिस अँड दिस इज वाय ऍक्सिस. स्क्रीनवर जर तुम्ही बघितलात तर ही एक्स ऍक्सिस आहे आणि ही वाय ऍक्सिस आहे. मग इथं जर तुम्ही कन्सिडर केलात तर इथून इथपर्यंत गेला तर हा काहीतरी 10 असेल. So if you are looking towards this pixel, so its x coordinate will be 10 and y coordinate will be 30. So this will be 10 30. So first of all the beam is moved to 10 30. So this is the point I am showing with the help of mouse. So this is the first point. So from this first point it is drawing the line. So up to which point? Up to the second point. So second command is line to 30 60. Line to 30 60. So this is nothing but this line. So this point. So this pixel is having its own x coordinate 30 and its own y coordinate 60. So you can you are able to understand. So this is nothing but the 30. X is 30 and y is almost 60. So this is nothing but the second end point of the first line. So this is the first end point and this is the second end point. So first end point is nothing but 10 30 and second end point is nothing but 30 60. Is it right? So like that the first line is drawn. After that again from this point. So this point is nothing but 30 60. म्हणजे मूव टू करायची गरज नाहीये, ऑलरेडी आपण त्या पॉइंटला आहोत. So that is nothing but 30 60 and from that point one more line is drawn. So what is the second end point of that line? Second end point of that line is nothing but 70 100. 70 100. So this is nothing but the second line. After that again here third line we are drawing. So for the third line we need to implement the move to command. So move to कुठल्या पॉइंटला मूव करायचंय? 40 20. So this is nothing but 40 and 20. 40 20. Is it right? Oh no, sorry. So this is not a point. This is nothing but the point. So this is nothing but 40 and almost 20. येते लक्षात? Are you getting my point? Everybody? Student?
Yes.
हा ही जर लाईन कन्सिडर केली तर ह्या पॉइंटचे कोऑर्डिनेट काय असणार आहेत? 40 आणि 20. आणि इथून लाईन कुठे ड्रॉ करतोय आपण? लाईन टू 50 30. So from this point we are drawing the line over here and after that we are coming back. So that is the second line and second line is nothing but 15 and 7. 15 and 7. Got it? Everybody? Yes? So
Yes,
this is
ma'am.
nothing but the picture. So on the screen picture is shown. So picture, you can take any picture. Here they have taken the picture of line. So you can take triangle also, you can take any rectangle also. Accordingly you need to write the commands. Accordingly you need to write the commands in the display file. So hope you got the clear idea how to write the commands in the display file and how to draw the picture on the screen. Is it right? So is it possible for you to take your own example? Yes? So
Yes,
is it possible for you to take your example? You can take, say, a rectangle. So for rectangle, can you tell me how many commands will be there? रेक्टँगल, तुम्हाला एक रेक्टँगल ड्रॉ करायचंय. मग तुम्हाला किती लाईन ड्रॉ करायला लागतील? 4 लाईन. पण पहिली लाईन ड्रॉ करण्यासाठी आपल्याला मूव टू कमांड वापरायला लागेल. पहिली कमांड काय असणार आहे? मूव टू. आणि त्याच्यापासून तुम्ही लाईन 2 करणार आहे. परत लाईन 2, परत लाईन 2 आणि परत लाईन 2. इज इट राईट? सो टोटल 5 कमांड्स यू रिक्वायर. आर यू गेटिंग माय पॉइंट? Yes? So if you want to draw the triangle, how many commands will be there?
5.
Triangle.
4 commands.
4 commands will be there. First command will be
Move to.
First move to, and after that 3 line 2. Is it right?
Line 2.
Good, good.
Yes.
These are nothing but the examples which we are taking in case of random scan display. So images are described in terms of line segments rather than pixels. So we used pixels in raster scan display, and we are using lines in case of random scan display. So display processor cycles through the commands. So it processes all these commands one by one, and accordingly the picture is get generated. So, okay, so this is nothing but about random scan display. So these are the 3 slides related to random scan display principle. So what the clear idea? So I given the example of lining shirt. If I want to design the lining shirt design, or check shirt, so like that, so in that case we need to draw the lines. So such designs are prepared with the help of random scan display principle. So again, these are prepared by the CRT only the principle will be different, method will be different. Okay, so can we proceed further? Any doubt?
No, ma'am.
Okay, so we'll proceed further to the next point. Actually, on the slide, they have given pros and cons of raster as well as random. So advantages to raster display. So what is the advantage to raster display? So its first advantage is lower cost. So cost required for raster display will be less. So it visits number of pixels. Uh, it visits almost all the pixels. जसं की मी तुम्हाला म्हटलं, तुम्हाला झाडू मारायचे असं अजूम करा की क्लासमध्ये बेंचेस ठेवलेले आहेत आणि ते बेंचेस साफ करून घ्यायचे. मी जर म्हटलं तुम्हाला सगळे बेंचेस साफ करून घ्या, तर त्या केसमध्ये तुम्ही काय करणार, कुठल्या तर एका लाईन मधून स्टार्ट करणार आणि फास्ट आपलं वन बाय वन तुम्ही सगळे झाडून घेणार. आणि जर मी म्हटलं तर सगळे बेंचेस नाही साफ करायचे तुम्हाला, पहिल्या रो मधला मे बी 7वा बेंच साफ करायचंय, दुसरा रो मधला मे बी 3रा बेंच साफ करायचंय, तिसऱ्या रो मधला मे बी 9वा बेंच साफ करायचंय आणि 4थ्या रो मधला मे बी 5वा बेंच साफ करायचंय. तर अशा ह्या सेकंड केस मध्ये जर तुम्हाला मी असं म्हटलं की तेवढेच बेंचेस तुम्हाला साफ करायचे, तर तुम्हाला काय काय करावं लागेल, तुम्हाला बेंच सर्च करावं लागेल. So you need to search the bench number, you need to search, and then you have to go to that particular bench, and then you have to clean that bench. So it means according to the part of implementation, जर मला ह्या 2 मेथड इम्प्लिमेंट करायच्या असतील तर पहिली मेथड इम्प्लिमेंट करण्यासाठी खूप सोपी आहे, पण दुसऱ्या मेथड मध्ये मला सर्चिंग करायला लागते आणि सर्चिंग करण्यासाठी मला कंपॅरिझन करायला लागतं. मी जसं की म्हटलं पहिल्या रो मधला 7वा बेंच, म्हणजे मला काय करायला लागेल, जोपर्यंत 7वा बेंच मला मॅच फाउंड होत नाही. आय एम टॉकिंग विथ रिस्पेक्ट टू द प्रोग्राम पार्ट ऑफ इम्प्लिमेंटेशन. So if I want to write a program to implement this scheme, so it requires more time. It requires more part of cost. So kind of logic, mostly in case of computer. So if the logic is best, so it requires more cost. And if the logic is worst, it requires less cost. For example, मी तुम्हाला म्हटलं 10 नंबर तुम्हाला प्रिंट करायचे. मी तुम्हाला म्हटलं तुम्हाला एक प्रोग्राम लिहायचंय, सी प्रोग्राम लिहायचंय आणि त्याच्यामध्ये 10 नंबर प्रिंट करायचे तुम्हाला 1 ते 10. तर फॉर एक्झाम्पल सपोज तुम्ही बिगिनर असाल, तुम्हाला जास्त काही माहित नाही सी लँग्वेज बद्दल, पण तुम्हाला प्रिंटएफ स्कॅनअप माहित आहे, तर तुम्ही काय करणार, 10 प्रिंटएफ स्टेटमेंट वापरणार. प्रिंटएफ 1, प्रिंटएफ 2, प्रिंटएफ 3, प्रिंटएफ 4, लाईक दॅट ऑनवर्ड्स. म्हणजे 10 प्रिंटएफ स्टेटमेंट वापरून तुम्ही एक प्रोग्राम राईट करणार आणि तो प्रोग्राम रन केल्यानंतर ऑटोमॅटिकली तुम्हाला 1 ते 10 नंबर दिसतील आउटपुट स्क्रीनवर. जर सपोज तुम्हाला अरेचा कन्सेप्ट माहित नाहीये, त्या केसमध्ये तुम्ही ही पहिली मेथड वापराल. आणि जर तुम्हाला अरेचा कन्सेप्ट माहित असेल तुम्ही काय करणार, फॉर लूप वापरणार. इज इट राईट? आर यू गेटिंग माय पॉइंट? Yes?
Yes.
So
Yes, ma'am.
if you know the concept, if you know the technique of for loop and array, so what you will do, you will take the help of array and you will display. So you will write the program. So in that program, first line will be for I is equal to 1, I less than 10, I plus plus. And in that for loop, only one statement will be there, printf %. Maybe for example, you used array a of I. So how many lines we used in the second program? So almost 2 to 3 lines. Is it right? Is it right? Yes.
Yes, ma'am.
In the second program, as we know the technique, so that's why we reduce the size of program. We reduce the size of program. पहिल्या प्रोग्राम मध्ये ऑलमोस्ट मला 10 ते 12 लाईन्स लागल्या होत्या, पण दुसऱ्या प्रोग्राम मध्ये मला हार्डली 2 ते 3 लाईन लागणार आहेत. जर मी हे दोन्ही प्रोग्राम कंपेअर केले तर दुसऱ्या प्रोग्रामची कॉस्ट हायर असणार आहे आणि पहिल्या प्रोग्रामची कॉस्ट लोअर असणार आहे. पहिला प्रोग्राम खूप सिंपल असणार आहे, त्याची कॉस्ट एकदम कमी असणार आहे. का तर एकदम सिंपल लॉजिक यूज केलेलं आहे त्याच्यामध्ये, आणि दुसऱ्या प्रोग्राम मध्ये चांगलं लॉजिक यूज केलेलं आहे, म्हणजे बेटर लॉजिक वी आर यूज इन द सेकंड प्रोग्राम, and that's why cost is high. So this is applicable in case of software also. So if the softwares, mostly the programs, what is software? Software is nothing but again big program. ज्या प्रोग्रामला कमीत कमी मेमरी लागते स्टोअर करायला आणि कमीत कमी वेळ लागतो एक्झिक्यूट व्हायला, असा प्रोग्राम बेस्ट प्रोग्राम म्हणून समजला जातो. ज्या प्रोग्रामला कमीत कमी वेळ लागतो एक्झिक्यूट करायला आणि कमीत कमी मेमरी लागते सेव्ह करायला, that will be the best program, but its cost will be high. And the program which requires more memory and more time, so it will be worst. So it is not a best program. So mostly we the computer engineers, we are trying to write the best programs. So that's why it is said that the programmer should apply the proper logic, best logic, so that the program size should be very, very small and it should take less amount of time to execute. So two things we need to consider while we are calculating the cost. First one is storage and second one is processing time. So processing time should be less and storage will be less. So it should require less space. It should require less space. So that kind of programs we should develop. So based upon that, cost is calculated. So in case of raster display, as we are using very simple technique we are using, so that's why the cost is low. And in case of random display, so in case of random display, as we need to search the pixels, which pixels we need to draw, so the cost will be high. So that's why here the advantage of raster is lower cost. It requires less cost because the technique of implementation is very simple. Next, it is applicable in field regions, shaded images. आताच मी तुम्हाला एक एक्झाम्पल सांगितलं, आपला कलर शर्ट. I told the example of plain shirt and लाइनिंग शर्ट. सो प्लेन शर्ट म्हणजे कुठल्याही कलरचा असू शकतो. सो दॅट इज नथिंग बट द शेडेड इमेज. सो द होल इमेज इज शेडेड विथ द हेल्प ऑफ कलर. सो देर मे बी वन कलर, देर मे बी मोर दॅन वन कलर. सो वेर एव्हर वी नीड टू फील द रिजन्स, जे काही रिजन दिलेले आहेत आपल्याला, जे काही पॉलिगॉन्स दिलेले आहेत, ते जर आपल्याला एखाद्या कलरनं फील करायचे असतील तर दॅट इज द एक्झाम्पल कमिंग अंडर रास्टर स्कॅन डिस्प्ले. सो शेडेड इमेजेस अँड फील्ड रिजन्स आर कमिंग अंडर raster scan display. And what are the disadvantages to raster display? A discrete representation, continuous primitives must be scan converted, that is fill in the appropriate scan lines. So just I said that what is the major disadvantage? Unnecessarily it visits to the pixels which are not part of the picture. So major second disadvantage, that is aliasing or jaggeds, arises due to sampling error when converting from a continuous to discrete representation. To understand this aliasing, so this is the aliasing or jaggeds. This is stated as a disadvantage of raster display. So you are able to see this diagram. या डायग्राम मध्ये जर तुम्ही बघितलात तर दोन क्रॉस लाईन आहे तिथे, आणि ह्या लाईन ज्या बघताय तुम्ही, सो इट टोटली डिपेंड्स अपॉन द रिझोल्युशन. रिझोल्युशन जर पुअर असेल तर त्या लाईन कशा दिसत आहेत? स्टेअर केस सारख्या दिसत आहेत. Is it right?
Yes, ma'am.
Student. जर तुम्ही हे लाईन बघितलात, या जर लाईन बघितलात तर त्या जागीज सारखं दिसतात. दिस इज कॉल्ड एज अ जागीज स्टेअर केस इफेक्ट. इट इज ऑल्सो कॉल्ड एज अ स्टेअर केस इफेक्ट. म्हणजे ती लाईन न दिसता आपल्याला स्टेअर केसेस असल्यासारखं दिसतात. आणि हे स्टेअर केसेस कधी दिसतात, जर आपलं रिझोल्युशन पुअर असेल तर. जर आपलं रिझोल्युशन पुअर असेल तर, फॉर एक्झाम्पल मी स्क्रीनवर सपोज मी 5x5 ची स्क्रीन घेतली. 5x5 म्हणजे किती पिक्सल आपण डिस्प्ले करतोय, 25 पिक्सल, म्हणजे पिक्सलची साईज खूप मोठी असणार आहे. मग मी एखादी लाईन जर ड्रॉ करायचं म्हटलं तर ती लाईन पिक्सल 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 मी अशी कनेक्ट करणार. असे कनेक्ट केल्यानंतर मला ते काय दिसणार आहे, ती लाईन दिसणार नाही. मी जवळून पाहिलं तर ते मला स्टेअर केसेस दिसतील, आणि मी जर खूप लांबून पाहिलं तर मला ती कमी थोडीफार लाईन दिसल्यासारखी दिसेल. So this is called as a staircase effect. So this is nothing but the aliasing. So this is the major disadvantage in case of raster scan display. So got the clear idea? So here it is shown with anti-aliasing, without anti-aliasing. So actually anti-aliasing, it is nothing but the technique used to overcome aliasing effect. जसं की व्हायरस आणि अँटीव्हायरस. व्हायरसेस जर आपल्याला रिमूव्ह करायचे असतील तर आपण अँटीव्हायरस सॉफ्टवेअर यूज करतो. तसंच अलायसिंग जर रिमूव्ह करायचं असेल तर रास्टर स्कॅन डिस्प्ले मध्ये अँटी अलायसिंग टेक्निक वापरतात. सो दिस इज अँटी अलायसिंग टेक्निक. म्हणजे ह्या डायग्राम मध्ये जास्तीत जास्त स्टेअरकेस क्लिअरली दिसतात आणि इथं थोडस तेवढे क्लिअर दिसत नाहीत. सो दिस इज द अँटी अलायसिंग इफेक्ट. So right now you can just keep in mind anti-aliasing, it is the solution on aliasing. So that again we are going to discuss in the 5th chapter in detail. So we are discussing different techniques for aliasing, how to remove aliasing. So we are using different anti-aliasing techniques over there. So some sampling methods we are using. So like that different methods are there which we are going to discuss in the 5th chapter. So for a while, just keep in mind that what is the major disadvantage of raster. So major disadvantage is nothing but aliasing. Got it? Okay. So it is also called as a discrete representation. Discrete representation. So it is not a continuous representation. It is somewhat looking like a discrete representation. Okay. So scan converted in the sense, so we need to scan each and every scan line. So this is the major disadvantage of raster. So any doubt, raster scan display advantages and disadvantages? Come on, students, are you listening to me?
Yes, ma'am.
Yes, ma'am.
Okay, so two advantages we discussed and two disadvantages we discussed with respect to raster scan display. Again, in the next here the comparison is shown. So instead of showing this slide, I will move to the next slide. So over here, so I have shown the comparison. So almost 7 differences I have found out. So are you able to see the screen?
Yes, ma'am.
So up till
Yes,
now we
ma'am.
discussed about random scan display and raster scan display, and here we are able to see the difference, raster scan display and random scan display. So first difference, in raster scan display, the beam is moved all over the screen, one scan line at a time from top to bottom, left to right. Actually it is not right to left, it is left to right. Left कडून right ला जातोय इलेक्ट्रॉन बीम, and then back to top. म्हणजे पहिल्यांदा तो टॉप पासून सुरुवात करतोय आणि परत कुठे येतोय, बॉटमला येतोय आणि बॉटम मधनं परत तो टॉपला जातोय. सो दिस प्रोसेस इज गोइंग ऑन कंटिन्युअसली बिकॉज इट इज रिफ्रेश CRT. इज इट राईट? सो लाईक दॅट इन रास्टर scan display, the beam is moved all over the screen, one scan line at a time from top to bottom, left to right, and then back to top. But in random, how it works? In random, display beam is moved between the end points of the graphics primitives. Or instead of calling graphics primitives, you can call it as a graphics pictures, or whatever pictures we are drawing. So you can call it as a graphics, or you can call it as a pictures, or you can, in short, you can call it as a graphics primitives. Okay. So what in case of random, what it does, it moves in between end points of the graphics primitives. Is it right? What the clear difference? फर्स्ट डिफरन्स, पहिल्या डिफरन्स मध्ये रास्टर मध्ये इलेक्ट्रॉन बीम कसा मूव्ह होतोय, सगळीकडे मूव्ह होतोय, सगळ्या पिक्सलला व्हिजिट करतोय आणि त्यातले जे पिक्सल ड्रॉ करायचे तेवढेच पिक्सल ड्रॉ करतो. पण रॅन्डम मध्ये काय करतोय, तो एंड पॉइंट, लाईनच्या एंड पॉइंट पासून मूव्ह होतोय, प्रत्येक लाईनच्या एंड पॉइंटला जातोय, लाईन ड्रॉ करतो, परत दुसऱ्या लाईनच्या एंड पॉइंटला जातोय, लाईन ड्रॉ करतो, परत तिसऱ्या लाईनच्या एंड पॉइंटला जातो, लाईन ड्रॉ करतो, लाईक दॅट ऑनवर्ड्स. दॅट इज द पिक्चर इज ड्रॉन इन द फॉर्म ऑफ लाईन्स. सो दिस इज द फर्स्ट डिफरन्स. Next difference, in raster display the refresh process is independent of the complexity of the image. Is it right? इमेज किती का कॉम्प्लेक्स असे ना, तो त्याचं काम करत असतो. त्याचं काय काम आहे, तो पहिल्या लाईनला जायला पाहिजे, पहिल्या लाईनला म्हणजे टॉप टू बॉटम त्याला स्कॅन करायचंय, तो कंपल्सरीली पहिल्या लाईनला जाणार, तिथून लेफ्ट टू राईट मूव्ह होणार, परत दुसऱ्या लाईनला जाणार, लेफ्ट टू राईट मूव्ह होणार, तिसऱ्या लाईनला जाणार, लेफ्ट टू राईट मूव्ह होणार, लाईक दॅट ऑनवर्ड्स. सो इट डज इट्स वर्क as it is because it is fixed one, so it doesn't matter what kind of picture is it. So that is nothing but the complexity of image. Image कुठलीही असू दे, कशीही असू दे, तो त्याचं काम सोडत नाही. त्याचं काम काय आहे, पहिल्या लाईन पासून ते लास्ट लाईन पर्यंत मूव्ह व्हायचं, पहिल्या लाईन पासून लास्ट लाईन पर्यंत मूव्ह व्हायचं, स्कॅन लाईन वाईज मूव्ह व्हायचं. So that is the work done by the electron beam in case of raster display. But in random display, flickers, display flickers, then the number of primitives in the buffer becomes too large. So what it does here, so whenever the image will be somewhat complex, so it moves in between the primitives. In random display flickers, then the number of primitives in the buffer becomes too large. सो जसं जसं इमेजची कॉम्प्लेक्सिटी वाढत जाते, जर सपोज मी जर ट्रायंगल घेतलं तर 3च लाईन असणार आहेत, रेक्टँगल घेतलं तर 4 लाईन, एखादा पेंटॅगॉन हेक्सागॉन घेतला तर नंबर ऑफ लाईन्स वाढत जातात. मग जशा जशा लाईन वाढत जातात तसं तसं इन केस ऑफ रॅन्डम कॅन डिस्प्ले द वर्क ऑफ बीम विल बी गेट इन्क्रीज्ड. इज इट राईट? बट इन केस ऑफ रास्टर्स कॅन डिस्प्ले द वर्क इज फिक्स्ड वन. But in case of random scan display, however the complexity increases, accordingly its work is also get increased. What the clear idea? Yes, are you listening to me?
Yes.
Yes, ma'am.
So if the complexity get increases, so work also get increases in random, and in raster, so it is totally independent of complexity of the image. Image कसली का असे ना, कुठली का असे ना, it's totally independent on that image, it does the work. But in random, you can write in random, so the process is dependent on the complexity of the image. Okay, so this is the second difference. Third difference, graphics primitives are specified in terms of their end point and must be scan converted into their corresponding pixel in the frame buffer. It is, that is, scan conversion is required. In short, it is called as a scan conversion required, and in random scan display, scan conversion is not required. So scan conversion is nothing but it is related to scan line. So whatever number of scan lines are there, so all the scan lines should be scanned in case of raster display. But in case of random display, all the scan lines are not scanned. That's why it is said that scan conversion is not required. Got it? Raster मध्ये पिक्चर छोटा का असे ना, पिक्चर जर सपोज स्क्रीनच्या सेंटरला असेल, स्क्रीन खूप मोठी आहे आणि ट्रायंगल एकदम छोटासा आहे, ते सेंटरला ड्रॉ केलेलं आहे, म्हणजे त्या केसमध्ये रास्टरला काय करावं लागतंय, जरी पिक्चर खूप छोटा असेल तरी पण त्याला सगळे स्कॅन लाईन स्कॅन करावं लागतात. That is called as a scan conversion. But in case of random, so it is beneficial. So if picture is very small, it is located at the center of the screen. So in that case, it have to do very less work as compared to the raster. Is it right? So in raster, unnecessarily it have to scan all the scan lines. That's why it is said that scan conversion is required in case of raster, and in case of random, scan conversion is not required. Okay. So next. Next difference. So as scan conversion is required, scan conversion hardware is required. So just I said that what is scan conversion? That is moving from left to right, top to bottom, scan line wise. So for that purpose, internally it requires one software. So with the help of that software, that beam is moved from top to bottom, left to right. Like if I say draw, here to draw the triangle with the help of raster scan display. So in that case, you have to take the help of hardware. So extra hardware is required as scan conversion is required. So scan conversion is nothing but the software technique, and to implement that software technique, we require the hardware. So for a while, just keep in mind hardware is required. Okay, so however you will do the programs practically, so you will understand so what kind of hardware is required, etc. So as scan conversion is required, hardware is required, and here scan conversion is not required, so that's why hardware is not required. So in case of raster, scan conversion hardware is required, and in case of random, scan conversion hardware is not required. Next, in raster, cost is low. So just now in the advantage, we discussed how the raster cost is low. So in raster, cost is low, and in random, cost is high. So in random scan display, so the implementation part is somewhat complex. Implementation part is somewhat hard, and that's why cost is high. And in case of raster, implementation is very easy, so that's why cost is low. So got the clear idea about these 5 differences? Yes, are you listening?
Yes,
Ma'am,
ma'am.
last point. Yes, ma'am.
Anybody is having any doubt about these 5?
Ma'am, in last point, cost is low. Why?
So cost is low. I'm talking with respect to implementation. Implementation म्हणजे आपल्याला हे टेक्निक जर इम्प्लिमेंट करायचं असेल, त्याच्यासाठी एखादा प्रोग्राम लिहायचा असेल, तर प्रोग्राम रास्टर मध्ये प्रोग्राम लिहिणं खूप सोपं आहे, आणि रॅन्डम मध्ये तो प्रोग्राम लिहिणं खूप अवघड आहे. जसं की मी तुम्हाला आता एक एक्झाम्पल दिलं. तुम्हाला 1 ते 10 नंबर प्रिंट करायचे. सोपा प्रोग्राम कुठला आहे तुमच्या दृष्टीनं? 10 प्रिंटअप स्टेटमेंट लिहिणं. इज इट राईट? हे सोपं झालं. आणि जर अवघड कुठलं आहे, तुम्हाला फॉर लूप स्टडी करावा लागतो, RS स्टडी करावा लागतो, आणि ते दोन्ही स्टडी केल्यानंतरच तुम्ही तो 3 लाईनचा प्रोग्राम लिहू शकता. इज इट राईट? सो दॅट्स वाय कॉस्ट इज हाय. म्हणजे जर तुम्हाला चांगलं लॉजिक अप्लाय करायचं असेल, बेस्ट लॉजिक जर अप्लाय करायचं असेल, तर तुम्हाला भरपूर स्टडी करावा लागतो. So you need to invest your time. You need to invest your time. So that is nothing but time is calculated in terms of cost. जर प्रोग्राम कसा प्रोग्राम लिहायचा तुम्हाला? एकदम छोटा आणि ज्याला स्टोअर करायला कमी स्पेस लागणार आहे आणि ज्याला एक्झिक्यूट करायला पण कमी टाइम लागणार आहे, असा प्रोग्राम जर तुम्हाला राईट करायचा असेल, तर तुम्हाला भरपूर अभ्यास करावा लागतो. अँड दॅट्स वाय इट इज सेड दॅट कॉस्ट इज हाय. अँड जर प्रोग्राम खूप सिंपल तुम्हाला लिहायचा असेल, तर त्याच्यासाठी एवढा अभ्यास करावा लागत नाही. जसं की मी म्हटलं की 10 नंबर प्रिंट करायचे, मग हे 10 नंबर प्रिंट करण्यासाठी 2 प्रोग्राम आपण लिहितो इथं. पहिल्या प्रोग्राम मध्ये सिंपल प्रिंटअप स्टेटमेंट वापरतोय, आणि दुसऱ्या प्रोग्राम मध्ये प्रिंटअप वापरतोय, फॉर लूप वापरतोय, आरे वापरतोय. म्हणजे दुसरा प्रोग्राम राईट करण्यासाठी मला 3 कन्सेप्ट क्लिअर असायला पाहिजे, आणि पहिला प्रोग्राम राईट करण्यासाठी मला एकच कन्सेप्ट क्लिअर असला तरी चालतो. सो लाईक दॅट. So it is based upon it. It is called as a cost is low and cost is high. What now?
Yes, ma'am.
आलं लक्षात आता?
Yes, ma'am.
मी तुम्हाला दुसरं पण एक्झाम्पल सांगितलं. तुम्हाला मी फॉर एक्झाम्पल अजून एक एक्झाम्पल सांगते. तुम्हाला अटेंडन्स घ्यायचे. 1 ते तुमच्या क्लासमध्ये आता 1 ते 68 मुलं आहेत. मग मी तुम्हाला म्हटलं सगळ्या मुलांची अटेंडन्स घ्या, तर तुम्ही काय करणार? 1 पासून स्टार्ट करणार, 68 पर्यंत जाणार, जे की खूप सोपं आहे. आणि जर मी म्हटलं 1 ते 68 ची अटेंडन्स घ्यायची नाहीये, तुम्हाला काहीच मुलांची 10 मुलांची अटेंडन्स घ्यायची, जे 1 ते 68 मध्ये आहेत. मग ह्याच्यातलं तुम्हाला कुठलं अवघड वाटेल? कम ऑन. सेकंड जे सांगितले ते अवघड वाटेल की नाही? का तर त्याच्यामध्ये काय करायचंय तुम्हाला? 68 मधले 10 चूज करायचे. कुठले चूज करायचे ते तुम्हाला सर्च करावं लागते. पण पहिल्यामध्ये कसं होतं? 1 ते 68 एकदमच आपण कंटिन्युअस मध्ये होतं. म्हणजे पहिलं काम खूप सोपं आहे, पण दुसरं काम थोडंसं अवघड आहे. मग ते दुसरं काम करण्यासाठी आपल्याला जास्त वेळ लागतो, आणि पहिलं काम करण्यासाठी आपल्याला थोडा वेळ लागतो. सो बेस्ड अपॉन द टाइम, सो कॉस्ट इज डिसाइडेड. सो नाउ गॉट द क्लिअर आयडिया?
Yes, madam.
Got it? Everybody? म्हणजे थोडक्यात प्रोग्राम एकदम छोटा प्रोग्राम लिहायचा आहे, पण छोटा प्रोग्राम लिहिण्यासाठी आपल्याला लॉजिक पण माहिती असायला लागते. लॉजिक म्हणजे काय? जे काही आपण टेक्निक स्टडी करतोय ते सगळे टेक्निक्स आपल्याला परफेक्टली यायला पाहिजे, तेव्हाच आपण चांगलं लॉजिक अप्लाय करू शकतो. अदरवाईज वी आर अप्लाइंग द सिम्पल लॉजिक. आणि सिम्पल लॉजिक अप्लाय करण्यासाठी जास्त डोकं वापरावं लागत नाही, पण जर कॉम्प्लेक्स लॉजिक अप्लाय करायचं असेल तर आपल्याला डोकं भरपूर लावावं लागतं. सो दिस इज नथिंग बट द कॉस्ट. Okay, so this is somewhat difficult to understand at this level, but try to understand. So you can take the best example of that program. 10 लाईनचा प्रोग्राम लिहायचा आणि 2 लाईनचा प्रोग्राम लिहायचा. 10 लाईनचा प्रोग्राम खूप सोपा आहे, फक्त 10 प्रिंटअप स्टेटमेंट लिहिते मी, आणि दुसऱ्या प्रोग्राम मध्ये प्रिंटअप स्टेटमेंट, फॉर लूप, इफ फॉर लूप आणि आरए कन्सेप्ट वापरते. म्हणजे 3 कन्सेप्ट मला स्टडी करायला लागतात दुसऱ्या प्रोग्राम साठी. सो दिस इज नथिंग बट द कॉस्ट. ओके, सो एनी डाऊट? Good, you are asking the doubts. It means you are listening to me. Everybody is listening? Yes?
Yes.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so we'll move to the next difference. So these are the first 5. So next 3 more are there. So in raster display has ability to display area filled with solid color or pattern. So again the same example, plain shirt and lining shirt. So plain shirt is nothing but the area filled with solid color. In such applications we are able to use the raster display, and in random display has ability to draw only lines and characters. जर मला पिक्सल ड्रॉ करायचे असतील तर रॅन्डम मध्ये आपण ड्रॉ करू शकत नाही. सो इन रॅन्डम वी आर एबल टू ड्रॉ ओनली लाइन्स अँड कॅरेक्टर्स. But if we want to draw the shaded regions, so we are able to use the raster display. So that's why it is not like that. Raster is not best or random is not best. So it is based upon the application. आपण असं म्हणू शकत नाही raster scan display बेस्ट आहे किंवा रॅन्डम स्कॅन डिस्प्ले बेस्ट आहे असं आपण म्हणू शकत नाही. का तर दोघांचे पण ऍप्लिकेशन वेगवेगळे आहेत. मला जर असं एखादा सर्कल काढलाय मी आणि तो सर्कल फिल करायचा आहे, तर तो सर्कल फिल करण्यासाठी मला रास्टर स्कॅन डिस्प्लेच वापरावा लागतो. आणि जर मला लाईन ड्रॉज करायचे असतील तर त्या केसमध्ये मी रॅन्डम स्कॅन डिस्प्लेच यूज करायला पाहिजे. सो लाईक दॅट डिफरंट ऍप्लिकेशन्स आर देअर. So based upon application we are using raster display and random display. Okay, next simple difference, picture information is stored in frame buffer. So just now we discussed in raster picture information is stored in frame buffer, and in random it is stored in display file. Is it right? Got it? So everybody, are you getting my point?
Yes, madam.
ma'am.
जसं आपण सी प्रोग्राम राईट करतो, सी प्रोग्रामच्या त्या प्रोग्राम मध्ये काय काय आहे असं जर विचारलं आपल्याला तर आपण म्हणतो की त्याच्यात मी कोड राईट केलाय, त्याच्यात मी स्टेटमेंट्स राईट केलेले आहेत. सो दीज स्टेटमेंट्स और कोड इट इज नथिंग बट द पार्ट ऑफ माय सी प्रोग्राम. इन द सेम फॅशन, सो व्हॉट इज द पिक्चर इन्फॉर्मेशन? पिक्चर इन्फॉर्मेशन इज इन द फॉर्म ऑफ color. It is in the form of bits 0 1 0 1 0 1. So these are nothing but the contents of frame buffer. But in case of random scan display, how the picture information is stored? It is stored in the form of commands, and these commands we are storing inside the display file. म्हणजे रॅन्डम मध्ये त्या स्टोरेजला आपण डिस्प्ले फाईल म्हणतोय आणि रास्टर मध्ये त्या स्टोरेजला आपण फ्रेम बफर म्हणतोय. आणि फ्रेम बफर मध्ये काय असतात? फ्रेम बफर मध्ये बिट्स असतात आणि डिस्प्ले फाईल मध्ये काय असतं? डिस्प्ले फाईल मध्ये कमांड्स असतात. सो दिस इज द बेसिक डिफरन्स. And the last best or simple difference, the basic unit of picture is called pixel and the basic unit of picture is called line. So this I already discussed. So how we are drawing the picture in a raster, pixel by pixel, and how we are drawing the picture in a random, line by line. So hope with this you got the clear idea about raster and random. Yes?
Yes, ma'am.
So
Yes, ma'am.
if anybody asks the question on raster or random, so you can include these points also, whatever we have discussed in this difference. So this part you have to include as a part if they are asking question on raster. So all these points should be written in the raster along with the points which I covered in the PPT. Okay. So can we proceed further?
Yes, ma'am.
Any doubt?
No, ma'am.
So till now we just discussed the part of previous lecture. So yet we have not started any new point as a part of this lecture. Okay. So now we'll proceed further. So before proceeding further, can you give me some examples of applications where we are able to use raster and where we are able to use random? आता मी तुम्हाला सांगितलं रास्टर कुठं वापरतो आपण मोस्टली जे रिजन वगैरे शेड करायचे आहेत अशा ठिकाणी आपल्याला रास्टर स्कॅन डिस्प्ले वापरायचे आणि जिथं लाईन्स नि ड्रॉ करायचंय त्याला रॅन्डम स्कॅन डिस्प्ले म्हणतो. मग असे एखादे रिअल लाईफ मध्ये एखादं दुसरं एक्झाम्पल कोणी सांगू शकते मला? मी शर्टचं एक्झाम्पल घेतलं तसं तुम्ही एखादं एक्झाम्पल घेऊन सांगू शकताय? n number of examples are there. Yes, anybody?
मॅम
Come on, who is there?
ते रेल्वे स्टेशनच्या तिथं टाइम शो करण्यासाठी यूज केलं जातं.
Good. So it is the application of raster or random?
रॅन्डम ना?
हा. सो असे मोठे मोठे डिजिट दाखवले असतात बरोबर आहे? इज इट राईट?
Yes, ma'am.
हा. So this is the example of random. So any other example of raster? Raster? सिंपल एक्झाम्पल नॅचरल सीन. एखादा सीन मला जर ड्रॉ करायचा असेल तर मोस्टली सगळे कलर मला वापरायला लागतात आणि ऑलमोस्ट ऑल पिक्सल्स आय नीड टू शो. इज इट राईट? फॉर एक्झाम्पल झाड आहे, झाड दाखवायचंय मला तर झाड आपण रॅन्डमने ड्रॉ करू शकतोय का?
नाही.
Ha. So if I want to draw the tree, if I want to show the color of the tree, etc., natural scene, so I need to take the help of a raster. So pixel by pixel I need to draw. Is it right? So these are some of the examples of raster and random. So you can take your own examples, you can explore accordingly. So can we proceed further now?
Yes, ma'am.
Okay. So now we proceed further to the next point. So next point is nothing but color CRT monitor. Color CRT monitor. So up till now we discussed about black and white monitor. So we have used only two colors. But if we want to use more than one color, so it is nothing but the color CRT. So color CRT monitor uses different colors. It is called as a color CRT monitor. So using a combination of phosphors that emit different colored lights. So whatever screen we are taking with respect to CRT, so that screen is coated or it is coated with the help of different colored phosphors. So using a combination of phosphors that emit different colored lights. For example, असं अजून करा की 3 कॅरी बॅग आहेत तुमच्याकडे, एक रेड कलरची आहे, एक ग्रीन कलरची आहे आणि एक ब्ल्यू कलरची आहेत. RGB, these are the standard colors. ओके. आणि ह्या कॅरी बॅग तुम्ही एकाच्या समोर एक धरलेला आहात. 3 कॅरी बॅग आहेत तुमच्याकडे, एका समोर एक अशा कॅरी बॅग तुम्ही धरलेल्या आहेत किंवा असे पेपर्स आहेत, प्लास्टिक पेपर्स आहेत, ते एकमेकांच्या समोर तुम्ही धरलेले आहेत. सपोज एकदम पहिला आहे तो रेड आहे, त्याच्या मागचा आहे तो ग्रीन आहे आणि त्या ग्रीनच्या मागचा आहे सपोज तो ब्लू आहे आणि त्या ब्लूच्या मागून तुम्ही एखादा पेन असा फास्ट टोचवणार आहात त्याच्यामध्ये. तर त्या तिन्ही मधून जर त्या पेनची काय म्हणतात व्हेलॉसिटी जर खूप फास्ट असेल तर तो पेन तिन्ही मधून पण बाहेर येतोय. इज इट राईट? इट मीन्स ऍट लास्ट द रेड कलर इज दॅट, सो इट इमिट्स द रेड कलर. आणि जर तो स्लो स्पीडने येत असेल तर मे बी रेड थोडासा दिसेल आणि त्याच्यामध्ये बाकीचे कॉम्बिनेशन्स दिसतील. सो लाईक दॅट. सो दिस इज नथिंग बट द, ऑर यू कॅन टेक द पेपर. तुमच्या नोटबुकचा पेपर आहे आणि त्याच्यामध्ये तुम्ही पेन टोचला एका बाजूनं, जर दुसऱ्या बाजूला बघितलात तर पेनचा कलर जो कलर असेल तो कलर तिथं दिसेल तुम्हाला. तर पेपरचा कलर रेड असेल तर पेनचं टोक पण रेड दिसतं, पेपरचा कलर ग्रीन असेल तर पेनचं टोक ग्रीन दिसतंय, like that onwards. So this is nothing but the penetration of beam. So over here the role of pen is like a electron beam. So depending upon the velocity of electron beam, the color will be get highlighted on the screen. So over here this color CRT monitor takes the help of two techniques. So how the color CRT monitor works? So it is almost same like CRT monitor because it is a CRT monitor. So working of CRT monitor will be same, whatever we discussed in the last lecture. So it works in the same fashion, but it takes the help of colors. So again, two techniques are used by color CRT monitor. First technique is called as a beam penetration technique, and second technique is called as a shadow mask technique. So first, beam penetration technique, it is used in random scan monitors. Beam penetration technique, the beam is going to penetrate through different phosphor coats. So there may be different phosphor coatings. So one coating will be of red, one coating will be of green, another coating will be of blue. So if it is RGB model, like that onwards. So in random scan monitors, it is used. Next, it uses two colors. So it is limited to two colors only, red and green phosphor layers. Only two layers will be there in case of beam penetration technique. And next, color depends on the penetrated length of electron. So what is the speed of electron? Based upon that, the color will be get emitted. So only two phosphor coatings are used with CRT in beam penetration technique, and these two phosphors are nothing but red and green. So whatever shades are there with respect to red and green, so total red will be there, total green will be there. So combination of red and green. So there may be different shades of red and green. So if we mix 50% red and 50% green, so it will be third color. If we mix 20% red and 50% green, color will be different. So like that, different shades of red and green will be shown. So these are the color shades achieved in case of beam penetration technique, and especially beam penetration technique is used only in case of random scan monitors. It is not used in case of raster scan monitors. And the second method, so second method is somewhat best method. It is called as a shadow mask method. So it is used in a raster scan system. So it produces wide range of color with RGB color model. So especially it takes the help of all the three colors. So here limited colors are produced in case of beam penetration technique, but in case of shadow mask technique, n numbers of colors are produced. So that's why it is called as a somewhat better. So to understand this shadow mask, so here they have given color CRT monitors. Color CRTs are much more complicated, requires manufacturing very precise geometry, uses a pattern of color phosphors on the screen. So different color phosphors are used on the screen. So either the pixel will be in the circular pattern or it will be in rectangular pattern. So it depends upon the arrangement of electron guns. So electron guns are arranged in such a way that either circle will be get highlighted on the screen, or the rectangular pattern will be get highlighted on the screen. So this is nothing but the shadow mask technique. Okay, so over here, if you are looking to the diagram, so this is color CRT monitor. So it is called as a shadow mask CRT. So here three electron guns are used. So three colors it uses. So blue, red, blue, and green. So three guns will be there. Three guns. They are trying to highlight the electron beam. So these three guns are moving through one of the mask. आता इथं जे दाखवलंय, so this is nothing but the metal plate having some pores like our real life mask. आता now you are good familiar, due to COVID we are wearing the mask. तो mask म्हणजे काय, तो somewhat kind of filter, is it right? It filters air, and the clean air will be given to us, and whatever the particles will be there hazardous to the body, so they will be get thrown out. It filters it. So in the same fashion over here also, so only electron guns, only electron beam, it is penetrated through the shadow mask. So this is nothing but the shadow mask. It is the metal plate having the pores. So pores are almost mostly the circular shape. So either it will be circular shape, very rarely rectangular shape pores are used. So through these pores, so guns are transmitting and they are going to highlight on the screen. So this is nothing but the screen. So from one pore, all the three colors are coming together and they are just forming the picture like a delta. So delta is nothing but a triangular pattern. So you are able to see over here. So one triangular pattern is get generated of having the combination red, green, blue. So magnified phosphor dot triangle. So this is triangle. So this is called as a delta. So operation of delta delta shadow mask CRT. So it generates the pixel whose shape is somewhat looking like a delta, and that's why it is called as a delta. So in short, so the electron guns are get filtered, so only the data is taken towards the screen. So not any other kind of color is mixed with it. So it is called as a shadow mask CRT, and at last it reflects the color. So it will be the combination of red, blue and green. So again, it depends upon the velocity of these guns. So red may be very fast, green may be very slow, blue may be very slow. So in that case, which color will be get highlighted? So maximum red color will be get highlighted. So in the same fashion, if blue is very fast and other two are very slow, so in that case, blue will be highlighted. If the green is very fast and other two are slow, so green will be get highlighted. So like that, it totally depends upon the velocity of these electrons. So at what velocity they are traveling from the back side of the monitor to the front side of the monitor, that is on the screen. So depending upon that velocity, the color shade is decided. So that color shade is also called as a intensity. It is also called as a intensity. So different types of intensities will be there with respect to that particular pixel, and mostly it is used in case of raster scan display. So got the clear idea about shadow mask? So this is the technique used by color CRT. So color CRT uses two techniques. One is beam penetration technique, which is simple technique. So in beam penetration technique, it uses only two phosphors. In beam penetration technique, it is taking the help of only two phosphors. So these are the two phosphor coatings on the screen, and based upon it color is reflected. But in shadow mask, instead of phosphor, it is taking the help of guns. So different color, three color guns are used, and based upon these color guns and velocity of the electrons, the color is decided. So this is the basic difference between shadow mask and beam penetration. So beam penetration, it is used in case of random, and shadow mask, it is used in case of raster. So if you are talking in terms of applications also, जर रॅन्डम जर घेतलात तुम्ही तर रॅन्डम मध्ये मी स्पेशली म्हटलं की लाईन शर्ट मध्ये हार्डली किती कलर्स असतात? जर 4 लाईन्स असतील तर 4 कलर्स असतात, 2 लाईन्स असतील तर 2 कलर्स असतात, म्हणजे कमीत कमी कलर्स लागतात रॅन्डम मध्ये. बट इन केस ऑफ रास्टर, सो वी रिक्वायर n number of colors, and that's why shadow mask is used in raster and beam penetration is used in random. Got the clear idea? So these are the two techniques used by color CRT monitors. Any doubt? So regarding the same, I have shown the notes also. So beam penetration technique, it is used with random scan monitors. Two layer of phosphor, usually red and green, are coated onto inside of CRT, and displayed color depends on how far the electron beam penetrates into phosphor layer. Beam of slow electrons penetrates only outer red layer, that is electron having low intensity. Then only red color is reflected. In the same fashion, beam of green color will be get displayed, so only green color will be get displayed. Or if both are coming together, so again combination of color will be get displayed. So like that, this is regarding beam penetration technique, which is small. What is the disadvantage of beam penetration technique? As only two colors are used, so it is an expensive way to produce colors, random scan monitors, and also we get only 4 colors. Very few colors we are able to get with the help of beam penetration technique, and quality of image is not that much good. It is not that much good because it is applicable in case of random scan display. जर आपल्याला एखादा सॉलिड एरिया फील करायचा असेल आणि जर आपण बीम पेनिट्रेशन टेक्निक जर अप्लाय केलं तर आपल्याला जी काही इमेज मिळणार आहे ती अशी क्लिअर मिळणार नाही, त्याची क्वालिटी एवढी चांगली असणार नाही. So this is about beam penetration technique. And regarding shadow mask technique, these methods are usually used in raster scan display because they produce much wider range of color than beam penetration method. So these have 3 phosphor colors at each pixel position. One phosphor emits red light, another emits green, and third emits blue. So this is having 3 electron guns and shadow mask grid just behind phosphor coated screen. So this is the new technology which is included in case of shadow mask. Shadow mask grid is there, which is not there in case of beam penetration technique. To ensure that the individual electron gun emits correct phosphor dot, perforated metal grid is placed between the electron gun and face of CRT. So this is called as a shadow mask. So whatever that metal plate is inserted in between electron gun and screen, so that is called as a shadow mask. The perforations in the shadow mask are arranged in the same triangular pattern as phosphor dots. That's why it is called as a delta delta shadow mask. And what is the advantage of this? So this is easier and commonly used in high resolution CRT. So wherever the high resolution CRT is there, so over there the shadow mask technique is used. So high resolution, where whichever screens are high resolution screens, so over there we are using the shadow mask technique of CRT. So what got the clear difference between beam penetration and shadow mask? Yes, are you listening to me?
Yes, ma'am.
So what is the basic difference between these two? What you understood? What is the basic difference? At least 2 differences you can tell.
In BMAM, there will be a random scan system and shadow mask technique, raster scan
Good.
system. In the beam technique, there will be 3 colors. 2 colors are used,
Good.
red and blue only. And in shadow mask, there will be 3 colors are used, red, blue, and green.
Good, very nice. So this is the basic difference. At least you got. So one is used in raster and another is used in random, and one is having very limited colors and another is having very wider range of colors. And that's why mostly we are using shadow mask technique with CRT. So whatever CRTs are available nowadays with color monitors, so all are using the shadow mask technique because they are using wide range of colors, and that's why it is possible for us to get the good quality of pictures or images on the screen. So this is about color CRT. So under color CRT we are discussing one more point, that is color models. So under color CRT, so first point is nothing but the 2 techniques, beam penetration technique and shadow mask technique. Second point will be color models. So there are n number of color models, but out of that 2 are there for syllabus. So these 2 are nothing but RGB and CMYK. So again the applications are there. So first of all we'll discuss RGB. So these are again depending upon the colors. So RGB stands for red, green, blue. Red, green, blue. And over here I have shown the diagram. So if you are looking towards the diagram, so red circle is shown, blue circle is shown, and again green circle is shown. So if we mix all these 3 colors in same quantity, so we'll get the white color. So innermost color is W, white color. So in the same fashion, if we mix red and blue, we are getting the pink color. I hope you are able to understand this diagram. Yes or no? Yes.
Yes, ma'am.
So if we are mixing red and blue, so pink color will be get generated. If we mix red and green, yellow will be get generated. And if we mix blue and green, we are getting somewhat faint blue color. We are getting somewhat faint blue color. So this is nothing but the RGB model. And regarding RGB model, some of the characteristics are there. So it is an additive color model. That is, this color model is based on adding and mixing light. So it takes the help of light. So somewhat brightness is get created over here. So that's why it is called as a additive color model. It is trying to add or mix light in these colors. So like red and blue. So if you are getting inside the red, so over here pink. So if you try to differentiate pink and red, so you can define pink as a somewhat whitish color of red. जर मला पिंक डिफाईन करायचं असेल रेडच्या टर्म मध्ये, तर मी काय म्हणेन, पिंक. पिंकला पिंक न म्हणता मी काय म्हणेन, त्याचा रेड मधला थोडासा ब्राईट कलर आहे. रेड टोटल रेड नाही आहे, तो जरा ब्राईट आहे. ब्राईट आहे म्हणजे पिंक कलर आहे. इन द सेम फॅशन ब्ल्यू, डार्क ब्ल्यू इज डिफरंट अँड somewhat pinkish color is different. So that is, in short, light is get added in the color. So that's why it is called as a additive color model. That's why it is called as a additive color model. जसे की तुम्हाला फॉर एक्झाम्पल, आता तुम्ही मोबाईल घेऊन बसलाय, तुम्ही जर असं उजेडात बसला असाल तर तुम्हाला असं मोबाईलची स्क्रीन पण अशी काय म्हणतात, ब्राईट ब्राईट दिसायला लागते. आणि जर तुम्ही अंधारात बसला असेल तर ती अशी थोडी थोडी डार्क डार्क दिसायला लागते. सो लाईक दॅट, दिस इज नथिंग बट द additive color model. So when you add red, green, blue light together, you will get the pure white color. RGB is primarily used for designing elements that will be displayed on TV. So mostly the RGB color model is used on in TV technology. Also it is used in computer monitor, also it is used in mobile phones, also any other kind of sources of light. जे काही आपण डिस्प्ले डिव्हाइसेस वापरतोय, जे काही डिस्प्ले डिव्हाइसेस लाईटचा वापर करतात, अशा डिस्प्ले डिव्हाइस वर RGB कलर मॉडेल वापरलं जातं. सो सम बेसिक एक्झाम्पल, सिम्पल एक्झाम्पल्स आर नथिंग बट आवर टेलिव्हिजन, मॉनिटर, computer monitor and mobile screen. So you can keep in mind these three examples. These are the best example for RGB color model. So this is about RGB color model. So it is a device dependent color model. ह्या RGB ला डिव्हाइस डिपेंडंट म्हटलेलं आहे. सो इट इज डिव्हाइस डिपेंडंट कलर मॉडेल. फॉर एक्झाम्पल, एखादी डायग्राम जर मी कम्प्युटरवर बघितली तर ती जरा मला वेगळी दिसते, आणि तीच डायग्राम मी जर मोबाईलवर बघितली तर ती जरा वेगळी दिसते. सो दॅट्स वाय इट इज कॉल्ड एज अ डिव्हाइस डिपेंडंट. आर यू एग्री विथ मी? Yes? Are you getting my point?
Yes.
Yes,
If
ma'am.
you see the same diagram on mobile, एखादी पीपीटी आहे, आता जी मी पीपीटी डिस्प्ले केली आहे, मी बघतेय, मला थोडंसं वेगळं दिसतंय, आणि तुम्ही तेच तुमच्या मोबाईलवर बघताय, ते थोडंसं वेगळं, म्हणजे तुमच्या मोबाईलवर थोडं जास्त ॲक्युरेट दिसतंय. बिकॉज माय कम्प्युटर स्क्रीन इज समवॉट बिग, लार्ज, सो मे बी आय एम नॉट एबल टू सी दॅट मच क्लिअर. So the quality of image differs device to device. That's why it is called as a device dependent. That's why it is called as a device dependent. So it totally depends upon the resolution of the screen. So device, त्यामुळे मोबाईल वगैरे आपण परचेस करत असताना मोबाईलचं रिझोल्युशन विचारलं जाते. रिझोल्युशन किती आहे? रिझोल्युशन जर चांगलं असेल तर आपण मोबाईल घेतो, का तर आपल्याला ॲक्युरेट, यू आर गुड फॅमिलियर विथ मोबाईल. बऱ्याच वेळेला आपण फोटो घेतो, बऱ्याच वेळेला आपण असं पण म्हणतो, तुझा कॅमेरा खूप छान आहे, तुझ्या कॅमेऱ्याची क्वालिटी खूप छान आहे, माझ्या कॅमेऱ्याची क्वालिटी एवढी चांगली नाहीये. सो दॅट इज नथिंग बट इट डिफर्स ड्यू टू द रिझोल्युशन. So based upon the resolution, quality of the picture is decided. So like that, RGB color model, it is used in every device, that is television, computer, monitor, mobile phones, etc. But again, it is device dependent. So if we change the device, so its quality will be get differ. So that's why it is called as a color dependent, device dependent. It is a device dependent color model. So any doubt about RGB? Anybody is having any doubt? These are the small points which we are discussing under color CRT. So color CRT, it is the main point. Under color CRT, so we discussed first 2 points, that is beam penetration technique and shadow mask technique. So these are the two sub points, and the next sub point is color model. So color model, under color model again sub point is RGB. So red, green, blue color model. So got the clear idea where to use this color model? So once we discuss the second model, again you are able to get the clear idea. So second model is CMYK. So C stands for can, M stands for magenta, Y stands for yellow, and K stands for black. It's not B, it's K. So it is somewhat different. So K stands for black. So these are the these are the colors. So actually the basic colors are can. So you can pronounce according to your own. So san or can. So can, magenta, and yellow. These are the three basic colors. And if we combine these three colors, we are getting the fourth color as a black color. We are getting the fourth color as a black color. So if we are mixing these two colors, so we are getting somewhat blackish color. आता मागच्या मॉडेल मध्ये काय होत होतं, आपल्याला दोन कलर मिक्स केल्यानंतर थोडेसे व्हाईटिश कलर मिळत होते. That's why that was called as an additive model. But over here, somewhat blackish color we are getting. So if we mix can and magenta, we will get the can and magenta. So we'll get the blue color. So over here, blue is written. Again, magenta and yellow, red color we are getting, and can and yellow, green color we are getting. So that is nothing but again RGB model. So this red, green, and blue, these are somewhat dark colors. So we are getting the dark colors after combination of these colors. So that's why it is called as subtractive color model. It is a subtractive color model. So what do I mean by subtractive? A subtractive color model works exactly opposite from an additive color model. It works by partially or entirely masking certain colors from white. So it is masking certain colors from the white. It is trying to filter the white color. Masking is nothing but filtering. So it is trying to filter the white color. So ह्या मॉडेल मध्ये काय केलं जातंय, व्हाईट कलर बाहेर काढलं जातंय. It means it is trying to show the dark colors. So CMYK is also a device dependent color model. So like RGB, it is also color device dependent. Now we'll see the majorly the applications where we are able to use the CMYK color model. So it is mainly used in printing of posters. It is mainly used in printing of posters, brochures, business cards, books, or magazines. Okay, so got the clear application. So where we are using RGB? RGB we were using with the devices which are using the light. And CMYK we are using mostly with the papers. So we are using this color model for printing of posters, brochures, business cards, books, or magazines. It means in CMYK we are using ink, and in RGB we are using light to reflect the color. Got the clear idea? येते लक्षात? बेसिक डिफरन्स काय आहे दोन मॉडेल मध्ये? आरजीबी मध्ये आपण काय वापरतोय, कलर तयार करण्यासाठी लाईट वापरतोय, इलेक्ट्रॉन गन वापरतोय. But in CMYK we are using the ink. We are using the ink, and with the help of that ink we are producing the papers, that is the posters, brochures, cards, books, or magazines. So you are good familiar with magazines. जर तुम्ही मॅगझिन न्यूजपेपर वगैरे बघितलात तर त्याच्यावर असा कलर थोडाफार पसरलेला असतो. So that is due to dark color, due to black color. So that's why it is called as a subtractive color model. Are you getting my point? Is it right? Yes or no? जर न्यूज पेपर घेतले तर त्या पेपरचा कलर लागतो पण कधी कधी एखादा काही पदार्थ वगैरे जर त्याच्यावर ठेवला असेल तर त्याचा कलर कधी कधी त्या पदार्थाला लागतो पण. So that's why it is called as subtractive, because it is trying to mix the black color instead of mixing the white color. So that's why it is called as a subtractive. So what are the major differences between these two colors? So RGB color uses RGB, red, green, blue colors, light, and CMYK color model uses can, magenta, yellow, and black inks. So it takes the help of ink. Further, the RGB is additive model and CMYK is subtractive model. Further, both are device dependent, and the major last difference is nothing but RGB is used with devices which are using light, and CMYK is using ink. So wherever ink is used for printing purpose, so in such cases the CMYK model is used. So mostly CMYK model is used in case of printers, in case of plotters, etc. So wherever the kind of printing is going on. Okay, so this is nothing but the color models. Any doubt about color models? Come on. Yes,
No,
students,
ma'am.
are you listening to me?
Yes, ma'am.
Okay, so under this point, what we
Yes,
covered,
yes, ma'am.
we have started color CRT monitors. So under color CRT monitors, we discussed about basic concept of color CRT. So what is color CRT? It is CRT itself, only it takes the help of colors. So up till now, whatever we discussed that with respect to black and white CRT, but now we are discussing about color CRT. So it takes the help of color. So that's why it is called as a color CRT monitor. So CRT monitors which are using different colors are called as a CRT monitors. And how these colors are generated? So colors are generated with the help of combination of phosphors and combination of electron guns. So two techniques are used by color CRT monitors. One is beam penetration technique, another one is the shadow mask technique. And after that, we discussed the color models. So how many color models we discussed? We discussed two color models. One is the RGB color model and another is the scan color model. CY. CY. What is that? Come on. Are you listening to me? Yes.
Yes.
Students. Hello.
Yes, ma'am.
Yes,
So two
ma'am.
color models we discussed, RGB and CMYK.
Yes, ma'am.
Two color models we discussed, RGB and CMYK. So these 3 points, beam penetration technique, shadow mask technique, and color models we discussed under color CRT. Now the next point is, actually this is the last point. So can we discuss right now? Again, it is somewhat big point. Yes?
नको
नको
मॅम
का?
नको मॅम आता नको
मग रिवाइज करायचं का आपण काय काय डिस्कस केलं आतापर्यंत?
नको मॅम
So you have to revise.
हा मॅम
So I
हा
will ask the questions to you people. So I will minimize my screen. Okay, so last 10 to 15 minutes are remaining. So we'll revise whatever we discussed up till now. So come on, who will tell me the first point? What we discussed under this chapter as a first point? So only 44 students are here. So initially almost 53 students were there. So don't know why the students are leaving from the lecture. Maybe some network issue may be there. Okay, let it be. Come on, who will tell me what we discussed? First point. We are going according to the part of syllabus. Are you writing the points in the notebook? Yes? Amruta Dongre.
येस मॅम
Amruta. So are you writing in the
येस
notebook?
मॅम येस
Okay.
मॅम
So whatever I taught up till now, have you written everything in the notebook?
I have completed up to CRT monitor, ma'am. Video display device.
Good, good. So today we have covered the part which after the CRT. So you can write
Okay.
words. And one more thing, whatever PPT I have provided, especially with respect to first chapter, so almost all the notes I have covered in that PPT. जर तुम्ही नोट्स वेगळे असतील असं समजत असाल तर असं काही नाहीये, नोट्स काही वेगळे नाही आहेत, जे काही पीपीटी वर दाखवलेलं आहे, सो आय हॅव टेकन इट फ्रॉम द नोट्स इटसेल्फ. So if you want notes separately, I will share it also. But almost PPT is the only thing which you require to prepare the first chapter, especially. And for the third chapter onwards, we are taking some of the examples, so that may not be there on the PPT. Okay, so next, who will tell me the first point? Naneshwar? Naneshwar Lohar? Naneshwar is there? In the participant list, he is there. Naneshwar Lohar. Not listening. Naneshwar, unmute your audio and give me the answer. Naneshwar Lohar. So it seems Naneshwar is not listening. Okay, next, Goraknath. Goraknath Shejal. Gorakshanath. He is also not listening. Next, Kalyani. Yes, unmute your audio.
Yes, ma'am. Yes, ma'am.
Okay, so which was the first point? Okay, Naneshwar Lohar has written the attendance. Okay, not listening. Okay. So what was the first point we discussed in this chapter? Kalyani.
Yes, ma'am. Computer aided design.
I'm talking about first point. So that is the part of application. Before application also we discussed something.
What is computer graphics?
Good. What is computer graphics? Can you define?
Computer graphics is branch of computer science, uh, which relates to creation, manipulation, and storage of geometrical objects and their images.
Good. It is creation, manipulation, storage, and one more, display.
Displaying.
So these are the four operations which are majorly we are doing on the image or picture. So it is related to these four operations, and throughout the syllabus we are discussing about these four operations. Good. Okay. Next, Gorakshanath is there now online. Gorakshanath, unmute your audio.
Yes, ma'am.
So can you enlist all the applications of computer graphics?
Yes, ma'am. Yes.
Come on.
First application, computer aided design. Second, presentation graphics. Third, computer art. Fourth, entertainment. Fifth, education and training. Sixth, visualization. Seventh, image processing. And eighth, graphical user interfaces.
Good, very nice. So these are the 8 applications which we discussed under applications of computer graphics. Good, Uraksh. So listen, in between you are not listening. So I called number of times. So any problem you were facing? Any network issue was there? Goraksh?
Yes, ma'am. Yes, yes.
Okay. So you may be facing some network issue. Let it be. Okay. So next, after application, which point we discussed? Who will tell me? Next, Mayur. Mayur Ghadge. So while I'm asking the questions, you can unmute your audio and give me the answer. At least say yes. Let it be the answer may be right or wrong. Mayur?
Yes, ma'am.
Good. So which point we discussed after applications of computer graphics?
Display.
Huh? Come on. Unable to recall?
Yes.
Okay, so we have started video display devices. Is it right? We have
Yes.
started video display devices, and under video display devices, now can you tell me what we discussed?
CRT display.
Good. We have discussed about CRT. So we have discussed the working of CRT, cathode ray tube. After CRT, what we discussed? After CRT, Prerana, can you tell me? Prerana Shinde? Prerana Shinde?
Yes, ma'am.
Can you tell me under video display devices? First point we have discussed about CRT. After that, what we discussed?
Raster scan displays.
Good. We have discussed the raster scan display. After that,
Random scan displays.
good. Very nice. After that, we discussed the random scan display. And last,
CRT monitors.
color CRT monitors. Right.
Yes.
Okay. So all of you
Yes.
listen carefully. So in the third point, third point from the syllabus was video display devices. Under video display devices, we have discussed the first point as a working of CRT. After that, we discussed two principles. One is the raster scan display and another is the random scan display. And then we discussed the third sum point under the same, that is color CRT monitors. Now, who will tell what we discussed under color CRT monitors? Sanket. Kondu Bairi. Sanket. Sanket is there? Yes, Sanket. Sanket, unmute yourself.
Ma'am.
Yes, can you tell what we discussed under color CRT?
In color CRT monitor, there is a combination of phosphorus that emits a different color of light,
Good.
and in that beam penetration and shadow mask are the types.
Good. We have discussed two techniques of color CRT, beam penetration and shadow mask. And after that, we discussed about
Mm, After that, advantages of the color CRT monitor.
advantage of beam penetration we discussed, disadvantage of beam penetration we discussed, and again we discussed advantage of shadow mask. And after that, we covered
Color models.
color models we covered. Is it right? And under color model, how many color models we discussed?
There are two types of color models, RGB and CMYK.
Very nice. Two color models we discussed, RGB and CMYK. So again, can anybody tell me the basic difference between RGB and CMYK? Tejal? Tejal Surose?
Yes, ma'am.
Okay, so can you tell me the basic difference between these two models? What you understand?
Ma'am, in RGB,
Huh.
we use three colors, and when we add two colors, we get third one.
Huh. Good.
And in
CMYK.
CMYK,
Huh.
we use many colors.
Huh.
That's it.
Okay. So who will answer this question? If you have listened carefully, you will be able to answer this question. Basic difference between these two models.
In RGB, madam, it is additive color, and in CMYK stands for CMYK is subtractive color. In additive, in RGB, ma'am, there are three colors: red, green, blue light. They will get together and make we will get the pure white color. And in subtractive, madam, there will be exactly opposite to the RGB model.
Good.
It was
Good. Very nice. So at least you got something from me. So with this, almost 3 points, major points we covered from this chapter: introduction to computer graphics, applications of computer graphics, and video display devices. So only one last point is remaining. So that we'll see again in the next lecture. So thank you for your patience listening. Hope everybody has written their names and roll numbers in the chat box. Bye bye.
hello, ma'am.
Hello.
Hello. हाँ
Hello.
मैम, जे आपल्याला ते जे रेल्वे स्टेशनवरचे जे असते ना मॅम, ते कोणीतरी ऍप्लिकेशन सांगितलं
हा हा हा
ते रास्टर मध्ये येणार ना, रास्टर मध्ये येणार ना मॅम, कारण ते कंटिन्युअसली त्याच्यावर मूव्ह होत असते.
नाही नाही, तुमचं मोठ्या अक्षरामध्ये दाखवलेलं असते ना. त्याच्यामध्ये आता तुम्ही जर घेतलात त्याच्यात काही काही पिक्सल पण असे हायलाइट होतात. मग ते पिक्सल जर घेतले तर ते रास्टरचं ऍप्लिकेशन आहे, पिक्सल वाईज होत असेल तर. आणि लाईन वाईज होत असेल तर ते रॅन्डमचं ऍप्लिकेशन आहे.
मॅम ते अपडाऊन होतं ना, त्याच्यामुळं ते रास्टर मध्ये येणार ना.
रास्टर मध्ये येणार, रास्टर, राईट राईट.
हा.
ते पिक्सल फॉर्म मध्ये डिस्प्ले होते. बरोबर आहे, बरोबर आहे. गुड गुड, व्हेरी नाईस क्वेश्चन. गुड. ओके, सो एनी अदर डाऊट, एनीबडी? Yes? Okay, we'll stop now. Thank you. Have a nice day.